All right, in this video, we're going to look at something called the fundamental theorem of calculus, and we're going to explore something called a definite integral. Which is what you see right here. All right, we've already looked at indefinite integrals or general antiderivatives. Today we're going to focus on a definite integral. And a definite integral can be used to calculate the area under a curve. That's what a definite integral finds. It finds the area under a curve. So essentially this will be a shortcut for what we were doing yesterday, or in the previous two videos, where we were calculating the area under a curve using an infinite Riemann sum. So just so you know, like, we've seen the integral sign, and we've integrated f of x with respect to x. We found a general antiderivative. Now, a general antiderivative, or an indefinite integral differs from a definite integral in the sense that there are no upper or lower bounds of integration. So just to review, suppose I had this, okay? This means find the indefinite integral of x cubed with respect to x. And we know from our previous lessons that in order to integrate x cubed, I add 1 to the exponent, and I divide by that new exponent, and then I add a constant. All right? The general antiderivative of x cubed would be x to the 4th over 4 plus c. Now, how does that differ when I find the definite integral? All right? So same style of question, or it looks almost the same. The only difference is I have this upper limit of integration, my b value, and I have this lower limit of integration, my a value. So for starters, what I will do is I will find the antiderivative. So the antiderivative of x cubed will be x to the 4th over 4. Same rule, I'm adding 1 to the exponent, dividing by that new exponent, and then I'll put a plus c. Well, hold on a second. When we're doing definite integrals, it says to choose the antiderivative where c is 0. So I'm going to change the c to a 0, and in fact, if I'm changing that to a 0, I'm going to get rid of it altogether. So the antiderivative of x cubed is x to the 4th over 4. Now I want to evaluate this from -1 to 2. And what it says to do, it says to evaluate the antiderivative at your upper limit of integration. So in this case, I'm going to plug a 2 into this. I'm also going to plug a -1, my a value, my lower limit of integration, and then I'm going to subtract my two answers. So this will equal x to the 4th over 4 minus x to the 4th over 4. The only difference is I'm plugging in my b value first, okay? My b value, which in this case is a 2. I'm going to plug a 2 in, and then I'm going to plug a -1 in. My a value, and I'm going to subtract the 2. So this would equal 2 to the 4th, which is 16 over 4. This would equal -1 to the 4th is a +1 over 4. I've got 16 over 4 minus 1 over 4. Notice I didn't change that to a 4 because in order to subtract these, now I have a common denominator. The answer would be 15 over 4. Okay, the answer to that definite integral is 15 over 4. So again, find the find the antiderivative and use the antiderivative where the c value would be 0. So notice I don't write a plus c. And then fill in your upper bound, fill in your lower bound, and subtract the 2. And what this does is it actually gives you the area under the curve. So the area under the curve of y equals x cubed from -1 to +2. Couple things to note. The function has to be continuous from a to b. All all right, has to be continuous from A to B, and we'll talk about that in the next video. So before I go on and do any more definite integrals, I want to show you how this connects to what we did yesterday. And it's as simple as this. A definite integral is equal to an infinite Riemann sum. So this is what we did in the previous two videos. This is what we're doing today. Here is a question that we would have looked at yesterday using an infinite Riemann sum. The answer is negative 27 over 4. So I found delta x, b minus a over n is 3 over n. 3 minus 0 divided by n is 3 over n. I found my x of I star, which is a, 0, plus I times delta x, so to be 0 plus 3i over n, or just 3i over n. And then I found f of xi star. I filled a 3i over n into this equation for x. I worked it out, and I ended up with 27i cubed over n cubed minus 18i over n. Then I filled in my formula. All right, I multiplied. I used my sigma properties. I changed this to the cubic formula, this to the linear formula, and then I simplified and I evaluated the limit as n approached infinity of these two things. Degrees were the same. Here I end up with 81 over 4. Here I end up with 27 over 1. So I have 81 over 4 minus 27 gives me negative 27 over 4. That is what you did yesterday. This is like the long way. So if you want to compare it to differential calculus, this would be similar to using the limit definition of the derivative. And then after that, we started to learn shortcuts. Okay, we learned the power rule, the product rule, the quotient rule, the chain rule, and so on. Well, today, we're going to start using our shortcuts as well. So the first thing I'm going to show you is the definite integral. I'm going to do this exact same question using a definite integral. Okay, and let me just erase this. And we'll work from scratch. So it's the same question as the previous page. Find the area under the curve for f of x equals x cubed minus 6x between x equals 0 and x equals 3. But instead of using an infinite Riemann sum and getting an answer of negative 27 over 4, I'm going to use a definite integral, but I should still get the same answer. So to set this up, I can say that a equals the integral from 0 to 3, a value of 0, b value of 3. So a is 0, b is 3. And I'm integrating this function right here, x cubed minus 6x. And I'm integrating with respect to x. This is going to equal, well, the first thing I'm going to do is find the antiderivative of x cubed. That would be x to the 4th over 4. Then I'm going to find the antiderivative of negative 6x to the 1st. Well, that would be negative 6x to the 2nd divided by 2. All right, remember you're choosing the antiderivative where c is 0. And this would go from 0 to 3. I will clean this up. X to the 4th over 4. 6 divided by 2, that gives me negative 3x squared. And again, I'm going from 0 to 3. Now remember the move. I am going to fill a 3 in, my b value first. Then I'm going to fill a 0 in. So I'm going to find evaluate the antiderivative at b. So fill a 3 in. Then I'm going to evaluate the antiderivative at 0. And I'll subtract the 2. So first, the b value. This piece will equal, well, 3 to the 4th, that's 81 over 4. 3 squared is 9 times 3, that's a 27. Minus, then in these brackets, I'm filling in my a value, 0, 0. I think you would agree that 0 to the 4th is 0, divided by 4 is 0. 0 squared is 0 times negative 3, that's 0. So in these brackets, 0 minus 0, I've got nothing. So essentially, I have 81 over 4 minus 27. Well, 27 over 1 would become 108 over 4. 27 over 1 becomes 108 over 4. When I subtract, I end up with 81 minus 108 to give me negative 27 over 4. Now, check this out. Using a definite integral, I was able to come up with the area equal to negative 27 over 4, which is the same thing I got when I used an infinite Riemann sum, only it took a whole lot longer. Okay, so definite integrals calculate the area under a curve, or can be used to calculate the area under a curve. So let's just look at a few more examples, but keep in mind that it has to be continuous on A to B. So here's an example. So the first thing I'm going to do is I'm going to evaluate or calculate the antiderivative. The antiderivative of 2x cubed would be 2x to the 4th over 4. The antiderivative of negative 3x squared would be negative 3x cubed over 3. I'm adding 1 to the new exponent, adding 1 to the exponent, dividing by that new exponent. Add 1 to the 2, divide by that new exponent. This would become 7x squared over 2. This would become plus 2x. Now remember, I don't write plus c for a definite integral. I only write the plus c for an indefinite integral when there is no lower or upper limit of integration. And I'm going to evaluate this from 2 to 5. I'm going to simplify this. 2/4 would be 1/2, so it would be x to the 4th over 2. 3 divided by 3 is 1, x cubed, plus 7 over 2, x squared, plus 2x. Now, I'm going to find capital F, or the antiderivative at 5. So I'm going to replace all these x's with 5's. And then I'm going to replace all of the x's with 2's. So it'll be 2 to the 4th over 2 minus 2 cubed plus 7 times 2 squared. And we need a little extra space here. And this would be 2 times 2. So first, fill your b value in, 5, 5, 5, 5. Fill your a value in, 2, 2, 2, 2. All right, and work this out. So I am going to get 5 to the power of 4. That is 625 over 2. 5 cubed, that is 125. 5 squared is 25 times 7 gives me 175 over 2. Plus 2 times 5, that's a big 10. Minus 2 to the 4th, that's 16. Divided by 2 would give me 8. Minus 8. 2 cubed is 8. 2 squared, that is 4. Times 7 gives me 28. Divided by 2 gives me 14. And then I have a 2 times 2, which is 4. Now I'm going to work these out. Okay, I'll show you a little trick for this one. 625 and 175. So 625 over 2 and 175 over 2, they both have a denominator of 2, so I can combine those. How do I combine them? I got to add them. So that would give me 625 and 175 would give me 800 over 2. Well, 800 over 2, that's just 400. So I've got 400 minus 125. Okay, 400 minus 125 would give me 275 plus 10, that would give me 285. And then I'm going to subtract, well, this would be 8 minus 8, those are gone. 14 plus 4, that's 18. I want to subtract 18. Okay, so these guys right here, these four things, four terms, gave me 285. These four terms gave me 18, and I'm subtracting 18 from 285 to give me 267. Next one. All right, I'm going to rewrite this from 1 to 8. That's like saying 1 over, the cube root of x squared is like saying x to the 2/3. I'm going to find the integral of x to the negative 2/3. So I'm just going to rewrite the integral so that I can apply one of my rules or find the antiderivative. Okay, so brought the x to the 2/3 to the top. Now is where I will find the antiderivative. So I'm going to add 1 to the new exponent, add 1 to the exponent. So it's going to be negative 2/3 plus 1, or negative 2/3 plus 3/3. That would give me 1/3. And I'm going to divide by that new exponent. So I'm going to divide by 1/3. And I'm evaluating from 1 to 8. Well, let's clean this up. What is 1 divided by 1/3? Well, it's really 1 times 3. So to give me 3, x to the 1/3, or 3 times the cubed root of x. Now I have to find the antiderivative at 8 and the antiderivative at 1, and I will subtract those two things. So the 8 will go here, the 1 will go here. Remember, raising something to the power of 1/3 is like taking the cubed root. So this would be 3 times 2. The cubed root of 8 is 2. The cubed root of 1 is 1. This would be 3 times 1, so I'm going to have 6 minus 3, and I get an answer of 3. 3 would be the area under the curve, 1 over the cubed root of x squared, from 1 to 8. All right, let's keep rolling. Here's one, a little trickier, all right, or maybe a little confusing in the beginning because we've got t's in the numerator and t in the denominator. Well, that's okay, because what this is telling me is to actually divide everything by t. So I can rewrite this integral as the following. If I take t squared and divide it by t, I get t to the first. If I took t to the 1/2 and I divided it by t, I write my base down, I subtract the exponents. 1/2 minus 1, or 1/2 minus 2 over 2 would give me negative 1/2. This would become a plus t to the negative 1/2. So that is this term divided by the t in the bottom. And then a negative 2 divided by t, well, that's going to be negative 2 over t. Remember, this is a different rule. I don't want to bring that up and call it negative 2t to the negative 1, because if I add 1 to the negative 1, I get 0. I can't divide by 0. This requires my ln, my natural log. So I've just rewritten this original integrand to look like this. Now I can do my general antiderivative. So the antiderivative of t would be t squared over 2. The antiderivative of t to the negative 1/2 would be t to the 1/2 divided by 1/2. And the antiderivative of negative 2 over t would be negative 2 ln absolute t. Don't bother putting a plus c. Okay, it's a definite integral, and I'm going from 1 to 4. So this is going to equal t squared over 2 plus 2 t to the 1/2 minus 2 ln t from 1 to 4. So now I'm going to fill in my 4. I'm going to fill in my 1. And I'm going to subtract the two things. Minus. And that's another option too. Like you can just distribute this negative through all three terms in here if you'd like. So just change all these signs. It's up to you. Okay, it makes no difference. You're going to get the same answer either way. So I'm going to fill in a b value of 4. And I'm going to fill in an a value of 1. And I'm going to work this out. Let me clean this up a little. Give myself a little more room. All right, so 4 squared is 16. 16 divided by 2 would be 8. This would be 4 to the 1/2 would be 2 times 2 would give me a plus 4 minus 2 ln 4. All right, this would give me a minus 1/2 plus 2 minus 2 ln 1. Well, ln 1, okay, remember that would be just 0. Okay, so this would be 2 times 0. ln 4, that one doesn't really simplify. That's a greasy decimal. So this would be 2 times 0. So what I end up with is 8 plus 4, that's 12, minus 2 ln 4, and this would be minus 1/2 minus 2. So I'm going to distribute the negative over both of those. And when I do this, I've got 10 minus 1/2. Okay, so 12 minus 2 would give me 10. So 12 minus 2 gives me 10. Now I got to subtract 1/2. So 10 minus 1/2 would give me 20 over 2 minus 1 over 2 would give me 19 over 2. So I would end up with 19 over 2 minus 2 ln 4 for my answer. That would be the area under the curve. I will leave these two for you. All right. You can give those a try. The answers to those will be on your Teams page. All right, and I'll show the answers or the solutions to those perhaps in the next video.